الرحمن الرحيم. لقد كان لكم في رسول الله أسوة حسنة لمن كان يرجو الله واليوم الآخر وذكر الله كثيرا. ولما رأى المؤمنون الأحزاب قالوا هذا ما وعدنا الله ورسوله قالوا هذا ما وعدنا الله ورسوله وصدق الله ورسوله. وما زادهم إلا إيمانا وتسليما. من المؤمنين رجال صدقوا ما عاهدوا الله عليه فمنهم من قضى نحبه ومنهم من ينتظر وما بدلوا تبديلا. ليجزي الله الصادقين بصدقهم ويعذب المنافقين إن شاء أو يتوب عليهم. إن الله كان غفورا رحيما إن الله كان غفورا صدق الله العظيم. Wassalamualaikum warahmatullahi wabarakatuh.
Our brother Said Taufik Rizaldi Eskom, who has recited the Holy Quran beautifully. May Allah always give us guidance and grace. Amin. Ya Rabbal Alamin. The third agenda is singing national anthem Indonesia Raya. For all of participants, please make sure your camera is on during the sessions. So the next agenda is opening speech. Ladies and gentlemen, I immediately invite Dr. Hajah Asnia Aliyah MSI, the Dean of Faculty of Science and Technology UIN Sunan Gunung Djati Bandung, to give her speech. Please welcome to Dr. Hajah Asnia Aliyah MSI.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Bismillah walhamdulillah. Wassalatu wassalamu ala rasulillah wa ala alihi wa sahbihi ajma'in. Asyhadu an la ilaha illallah wahdahu la syarikalah wa asyhadu anna Muhammadan abduhu wa rasuluh la nabiyya ba'da. Dear distinguished guests, the Dean of the Faculty of Science and Technology of UIN Sultan Syarif Kasim Riau, Bapak Dr. Hartono MPD, Deans and Vice Deans of the Faculty of Science and Technology of PT KIN from all over Indonesia, dear notable speakers on this webinar, Profesor Dr. Insinyur Bambang Riyanto Trilaksono from Bandung Institut of Teknologi and Dr. Laurent Bobelin from ILSA, France, and the committee and all participants who I respect. Alhamdulillahirabbil alamin. Today we are all gathered here to take part in the second international webinar series in 2022, organized by the Faculty of Science and Technology UIN Sunan Djati Bandung in collaboration with the Faculty of Science and Technology UIN Sultan Syarif Kasim Riau. On this auspicious occasion, Professor Bambang will deliver a lecture with the title Artificial Intelligence and Robotics, and Dr. Bobelin will deliver a lecture entitled Security and High Performance Computing. We express our gratitude for the willingness of the two speakers to share their knowledge with us. I, the Dean of the Faculty of Science and Technology, would like to thank every single person involved for the success of this event. I want to thank the Dean of the Faculty of Science and Technology UIN Riau and his team, likewise with Pertamina Hulu Rokan, which is the sponsor of this event. Thank you for your cooperation. We are looking forward to having another collaboration with you. We would also like to thank all participants and for their enthusiasm. And not to forget, special thanks and appreciation to all the committee from UIN Bandung and UIN Riau who have dedicated their time preparing and organizing everything. And finally, on behalf of the chairs of the Faculty of Science and Technology UIN Sunan Djati Bandung, I officially open this event by saying Bismillahirrahmanirrahim. I hope you will enjoy this webinar. Wabillahi taufiq wal hidayah, wallahul muwaffiq ila aqwamit thoriq. Wassalamualaikum warahmatullahi wabarakatuh.
Now, let's have the doa. Will be led by our brother, Deden Farman, MAG. Mr. Deden Farman, time is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Ayuhal ikhwah liza, hayabina nad'u afan bil lughatil arabiyyah lianna du'a hadza bil lughatil arabiyyah laisa bil injiliziyah. Bismillahirrahmanirrahim. Hamdan sakirin hamdan na'imin hamdan yuwafi ni'amahu wa yukafi'u mazidah. Rabbana lakal hamdu kama yanbaghi lijalikal karim wa azimi sultanik. Allahumma shalli wa sallim wa barik ala Muhammadin wa ala alihi wa ashabihi wa man tabi'ahum bi ihsanin ila yaumil din. Allahumma ighfir lana dzunubana wa liwalidina warhamhum kama rabbawna shighara. Allahumma ighfiril mu'minina wal mu'minat wal muslimin wal muslimat al ahya. Bismillahirrahmanirrahim. Hamdan sakirin hamdan na'imin hamdan yuwafi ni'amahu wa yukafi'u mazidah. Rabbana lakal hamdu kama yanbaghi lijalikal karim wa azimi sultanik. Allahumma shalli wa sallim wa barik ala Muhammadin wa ala alihi wa ashabihi wa man tabi'ahum bi ihsanin ila yaumil din. Allahumma ighfir lana dzunubana wa liwalidina warhamhum kama rabbawna shighara. Allahumma ighfiril mu'minina wal mu'minat wal muslimin wal muslimat al ahya. Bismillahirrahmanirrahim. Hamdan sakirin hamdan na'imin hamdan yuwafi ni'amahu wa yukafi'u mazidah. Rabbana lakal hamdu kama yanbaghi lijalikal karim wa azimi sultanik. Allahumma shalli wa sallim wa barik ala Muhammadin wa ala alihi wa ashabihi wa man tabi'ahum bi ihsanin ila yaumil din. Allahumma ighfir lana dzunubana wa liwalidina warhamhum kama rabbawna shighara. Allahumma ighfiril mu'minina wal mu'minat wal muslimin wal muslimat al ahya. Bismillahirrahmanirrahim. Hamdan sakirin hamdan na'imin hamdan yuwafi ni'amahu wa yukafi'u mazidah. Rabbana lakal hamdu kama yanbaghi lijalikal karim wa azimi sultanik. Allahumma shalli wa sallim wa barik ala Muhammadin wa ala alihi wa ashabihi wa man tabi'ahum bi ihsanin ila yaumil din. Allahumma ighfir lana dzunubana wa liwalidina warhamhum kama rabbawna shighara. Allahumma ighfiril mu'minina wal mu'minat wal muslimin wal muslimat al ahya. Bismillahirrahmanirrahim. Hamdan sakirin hamdan na'imin hamdan yuwafi ni'amahu wa yukafi'u mazidah. Rabbana lakal hamdu kama yanbaghi lijalikal karim wa azimi sultanik. Allahumma shalli wa sallim wa barik ala Muhammadin wa ala alihi wa ashabihi wa man tabi'ahum bi ihsanin ila yaumil din. Allahumma ighfir lana dzunubana wa liwalidina warhamhum kama rabbawna shighara. Allahumma ighfiril mu'minina wal mu'minat wal muslimin wal muslimat al ahya. Bismillahirrahmanirrahim. Hamdan syakirin wa na'imin hamdan yuwafi ni'amahu wa yukafi'u mazidah. Rabbana lakal hamdu kama yanbaghi lijalikal karim wa azimi sultanik. Allahumma shalli wa sallim wa barik ala Muhammadin wa ala alihi wa ashabihi wa man tabi'ahum bi ihsanin ila yaumil din. Allahumma ighfir lana dzunubana wa liwalidina warhamhum kama rabbawna shighara. Allahumma ighfiril mu'minina wal mu'minat wal muslimin wal muslimat al ahya. Bismillahirrahmanirrahim. Hamdan syakirin wa na'imin hamdan yuwafi ni'amahu wa yukafi'u mazidah. Rabbana lakal hamdu kama yanbaghi lijalikal karim wa azimi sultanik. Allahumma shalli wa sallim wa barik ala Muhammadin wa ala alihi wa ashabihi wa man tabi'ahum bi ihsanin ila yaumil din. Allahumma ighfir lana dzunubana wa liwalidina warhamhum kama rabbawna shighara. Allahumma ighfiril mu'minina wal mu'minat wal muslimin wal muslimat al ahya. Bismillahirrahmanirrahim. Hamdan syakirin wa na'imin hamdan yuwafi ni'amahu wa yukafi'u mazidah. Rabbana lakal hamdu kama yanbaghi lijalikal karim wa azimi sultanik. Allahumma shalli wa sallim wa barik ala Muhammadin wa ala alihi wa ashabihi wa man tabi'ahum bi ihsanin ila yaumil din. Allahumma ighfir lana dzunubana wa liwalidina warhamhum kama rabbawna shighara. Allahumma ighfiril mu'minina wal mu'minat wal muslimin wal muslimat al ahya.
this definition is given by Russo and Norwich in their books. And Elaine Rich defined the AI is the study how to make computer do things at which at the moment people are better. As estimated by McKinsey Global Institute, AI will create a value of 13 trillions US dollar by 2030. And major areas in which AI will be applied widely are retail, travel, transport and logistic, automotive, assembly, basic material, advanced electronics, health system and services, high tech, telecom, oil and gas, and agriculture. A question may arise as to why AI is advancing so rapidly nowadays. To me, there are at least 4 reasons why AI is developing so rapidly in recent years. The first is that because availability of big data on the internet, as well as the data that is coming from Internet of Things. The second is to improve AI algorithms. The third is we see a more powerful central processing unit and a graphical processing unit. And at the same time, there are a variety of AI application. AI was originally started since 1950, but the recent advancement was started in 1980 with introduction of machine learning, in which we can teach a computer to learn from data and improve the experience. And since 2010, there is a huge development of deep learning, which is basically a part of machine learning that is inspired by how the human brain is working. So there are many at least 3 categories for machine learning. The first is supervised learning, in which we can teach a computer from the data that is equipped with its label in a supervised way. In unsupervised learning, we can teach a computer directly from the data, and reinforcement learning, in which there is an action that can be generated from the environment. A supervised learning is performed by using a huge data set. So as shown in this figure, for example, you have a number of images with their labels, and we can learn from this data through machine learning algorithms to construct a model. Then once a model is generated, then we can use the model with the new data. And for example, the AI model can classify the image of the data given. Deep learning relies on the concept of biological neuron. Biologists have studied that our brains contain of trillions of neurons, and this is a figure on the left show you about the biological neuron, which consists of nucleus, axon, synapse, and connected to other neuron. And we model this neuron by the simple neuron computation model, which is basically consisting of several inputs weighted by synaptic weights and sum together with a bias. And then to produce the output, we apply this result to a certain nonlinear activation function. And these neurons are connected in artificial neural network architecture consisting of the input layers, the hidden layers, and output layers. And when this artificial neural networks architecture is consisting of several hidden layers, then we say that we have a deep neural network architecture. One of the popular architecture of neural networks that receive a lot of attention in recent years is convolutional neural networks. So basically, convolutional neural networks consist of convolutional layers together with max pool layers, and then connected to a fully connected layer. And using this convolutional neural networks, for example, we can classify an image and make convolutional neural nets learns from a collection of image to classify an image given to the input of convolutional neural networks. In 2010, there was ImageNet competition in which there is a large number of ImageNet data set, and a number of architecture were tested. And in the figure on the left, you can see classification error of the winner of ImageNet competition, in which, as you can see over here, that the error is reducing significantly over the years, and even exceeded the human error. But you can also see from this figure that more and more layers are added in the convolutional neural networks. So there are a number of advancement of the convolutional neural networks architectures, such as AlexNet, VGGNet, ResNet, Inception, DenseNet, and so on. So for example, ResNet is basically a convolutional neural networks in which you can insert the so-called residual block within the convolutional layers. Next, let me discuss about various application of artificial intelligence. To my opinion, there are major AI application, which is computer vision, natural language processing, robotics, and big data analytics. Of course, there are a number of other application as well, but to my opinion, these four applications comprises the major application of artificial intelligence. For example, in computer vision, there are a number of tasks such as image classification, object detection and localization, visual activity recognition, image segmentation, image captioning, and 3D construction from 2D images. And all these tasks in computer vision can be effectively solved or performed using convolutional neural networks. This is another example of the AI application in computer vision. For example, given this figure, AI can generate automatically the caption where a person rides a motorcycle on a dirty road. Here is another example of the computer vision application of artificial intelligence, the so-called dense captioning on the left side. And on the right side, we can, for example, generate a caption for a series of frames that appear in a video. And this, again, is generated automatically by using artificial intelligence. Face identification and verification is also a popular AI computer vision application nowadays. Handwritten character recognition is another example where AI is widely applied, and you can find the handwritten character recognition in your handphone or tablets, for example. Visual question and answering. So, for example, given this figure, you can ask who is wearing glasses, and the AI can answer man for the figure on the left and woman for the figure on the right. AI can also be applied to classify a vehicle driving on the roads. So using a camera, for example, you can use AI to detect the maker of the vehicle and also its model. Speech recognition and synthesis is another example of the AI. For example, you can see on Siri in iPhone where you can ask with your own speech, and then the Siri can answer to that question. So in speech recognition, we basically convert speech to text, but in speech synthesis, we are converting the text to speech. Personal assistants such as Alexa from Amazon is another example of AI application, where you can instruct your personal assistants through your speech, and natural language processing allows a speech to be given as an input to Alexa. Chatbot is another exciting example of artificial intelligence. Again, you can interact with a chatbot using your own language. The second major application of AI is natural language processing, which can be divided into a number of tasks, such as part of speech tagging, sentiment analysis, parsing, machine translation, paraphrasing, summarization, and so on, in which AI is used and applied in this various natural language processing tasks. AI is also used in detecting anomaly. For example, in a network of a computer, we can use AI to detect the existence of attack to your computer. AI is also used for forecasting the data by using a feature window, and we can, for instance, convert this data forecasting into a supervised machine learning task. Today, we are dealing a lot with big data in terms of volume, velocity, variety, and veracity. And AI is applied mostly in predictive analytics and diagnostic analytics to the big data we have. This is the process on how AI is applied to generate predictive information automatically from huge data in big data. And shown here is the various architectures of artificial neural networks. I won't go into the detail of the various architectures of these neural networks. Next, let me introduce AI application in robotics and autonomous systems. So a robot is basically a machine, one programmable by a computer that is capable of carrying out a complex series of actions automatically. So shown in the right side of this slide, a mobile robot, a humanoid robot, and a robot that mimics a dog, and two arm manipulator that is working collaboratively. So robot can be constructed from mechanics, electronics, sensor, actuator, control, and of course the software, the AI that is used to make a robot behave more intelligence. So the robot can be found on drone, humanoid robot, robot that mimics animal, robot that explore other planets, animal-like robots, and also underwater robot. And AI is applied in robotics to perform a number of actions such as localization, navigation, and mapping, learning from the data, performing action, perception of the environment through sensors, to enable a robot to think about the fact, and to enable a robot to do a planning and to perform decision making. Shown here is the several humanoid robot that are popular nowadays, such as Sophia, iCap, and Asimo from Honda. There are a number of human-robot interaction where human can interact with a robot through different types of devices and also interface. And human can interact with a robot through the visual from a camera, or through a speech from a microphone and speaker, for example. But human can also interact with a robot through a touch sensor. Some consider that there will be a disruptive robot applications in the future. For instance, we will see a robot will be applied in retail, for medical surgery, for surveillance, smart kitchen, home assistance, and good delivery. To enable more intelligence robots, it should be equipped with some touch sight or hearing sensor. For instance, a recent robot used LiDAR, which allowed to measure the distance by using laser reflection. Shown here is several types of robot in which the robot use various kinds of sensing, and the robot has a capability of using AI applications such as natural language processing, and to detect an object through a camera. Recent exciting application of robot is a number of robots that perform mission collaboratively. So as you can see, for example, in soccer robot, they have to collaborate each other. A self-driving car is another example of AI application nowadays. And to enable the car to drive autonomously on the road, then they have to be equipped with a number of sensors such as LiDAR, radar, and camera. And deep learning can be used through the sensor to, for example, to detect the various objects surrounding the autonomous vehicle and to track them, which then to enable the autonomous car to avoid the obstacle. Here is an architecture of the autonomous vehicle, which consists of the sensor mapping and localization, route planning, autonomous perception, trajectory planning, vehicle kinematic and dynamic model, actuation, and the driving environment. And this is show you about the field of view of various sensors that are usually installed on the autonomous vehicle. So this show you the about the autonomous vehicle perception through a LiDAR on the right side, and on the left you can see how a camera installed on the autonomous vehicle can detect the object using 3D bounding box. Now, let us introduce to you about my own research project in developing an autonomous tram using artificial intelligence. So we started last year when we collaborated with PT INCA through the LPDP funding resource, where we develop a tram driving assistance, which, for example, can detect the object, can avoid a collision, can assess the speed limit, and also can recognize the human driver as well as to provide the driver attention warning. And in this year, we are developing a fully autonomous tram without the human driver, with additional features such as adaptive cruise control, autonomous emergency braking, and traffic sign recognition. And this is the show you about the sensor positioning on our autonomous tram, because the tram will drive on the road mixed with the other traffics, including a car, a motorcycle, as well as pedestrian. This figure shows you about the positioning of the camera, GPS, LiDAR, and also radar. And our autonomous systems will be connected by drive-by-wire system on the autonomous tram. So as you can see here, the core of our autonomous system is embedded GPU, which is a computing device where all the AI and deep learning algorithms are implemented to enable the tram to drive autonomously. Shown here is the image segmentation, which detects the object and also detects some drivable area. And this is shows you about how the camera in our autonomous tram can detect the object captured by a camera. And this shows you about the fusion between LiDAR and camera, which is capable of detecting the object using a 3D bounding box. This is another example of object detection using a camera, and this is the field testing at the PT Inca facilities in Madiun. And this show you about the object detection using a LiDAR that is used in our autonomous tram. And this is this show you about the fusion between LiDAR and camera to detect object based on 3D deep learning model and also 2D deep learning model. Finally, I will introduce briefly about my own AI startup. So one of our product is an unmanned store in which we can have an offline store such as Alfamart or Indomart, but the guests can purchase the available items without using the cashier. So once the customer get the items they want to purchase, then they can leave the unmanned store, and their digital wallet will be charged in accordance with the total price of the items they purchase. Automatic license plate recognition is another example of the use of AI for detecting digits license plate of the vehicle. Face recognition is already deployed in a number of company and is used for recording the attendance. Recently, we also developing a textile defect detection using camera and deep learning, in which using AI we can detect a defect that is occurring in textile, and even we can classify its defect categories. During the pandemic, I was also in charge of chairing a team, a national multidisciplinary team, in which we use AI to detect COVID from CT scan and X-ray. As a final note, I would like to quote from a book by Nick Paulson and James Scott entitled Artificial Intelligence Quotient: How People and Machines Are Smarter Together. A revolution of intelligent machines, from self-driving cars to smart digital assistants, is now remaking our world, just as the Industrial Revolution remade the world of the 19th century. Artificial intelligence is not some science fiction droid from the future. It is right here, right now, and it is changing our lives at lightning fast speed. Thank you.
Okay, thank you very much, Professor. Okay, how the material is very good and clearly for the introduction about the artificial intelligence and robotic and autonomous in industry, for example, the vehicle and etc. How about the participants? Still okay? Do you have question? I want to looking for the questionnaire. And don't forget, we have 3 door prizes for the best participants. Okay, we have one question. We have a questionnaire from Iis Afrianti. Would you like to open your, where is? Okay, Mrs. Iis Afrianti. Any else? Any question? Okay, Professor, maybe before the others, I want to ask about the training for the application. How much the training data we should prepare for this application?
Well, it actually depends on the types of the applications. For example, for detecting license plate on the vehicle, we have to collect thousands of images. Then using the data collected from camera, we can train the AI model to perform automatic detection of the license plate. We also, for instance, collected thousands images for example, for use in autonomous tram using a camera. So we perform field testing to capture the images and videos from the street. We perform it in Solo and also in Madiun, and we collect thousands of images, and then from this collected images we can train our deep learning model to enable the object detection and also tracking. So in short, we have to collect hundreds and maybe thousand or 10,000s data to train the model effectively.
Okay, thank you. Before continue, I look some person who raised hand. At the first is Mrs. Iis Afrianti. Are you ready, Mrs. Iis Afrianti? Iis. Okay, if not, we go to Muhammad Ihsan.
Oh, let me answer a question that on chat by Corey by Said Taufik Rizaldi Bafagi. So the question is in regards to transfer learning in convolutional neural networks, and what is the advantage and disadvantage of using transfer learning. So transfer learning is one of the key tasks in the machine learning and deep learning application. In practice, you can start with a pre-trained model that is available and is trained by a certain data set, and you can have your own data set, which is not so huge, can be smaller. Then in this situation, you can use transfer learning effectively. So, for example, you can use the pre-trained convolutional model. You can, for example, use only the convolutional layers to extract the feature of the images, for example, and you can you can perform tuning of the weights of fully connected layer, for example, for your task. So this is very effective in practice. What is the disadvantage of transfer learning? The disadvantage if you have or you don't have a pre-trained model which is similar to your task, then effectively transfer learning cannot be used to perform well.
Okay, thank you, Professor. Okay, now maybe Muhammad Ihsan, you can unmute your sound. Okay.
Okay.
We cannot hear your voice.
Can you?
Yes.
Can
no.
you hear?
Yes. Yes. No. Yes.
Okay. Tes.
Yes. Okay.
Okay. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Before that, thanks for the chance that I can ask. Let me introduce myself. My name is Muhammad Ihsan Nur Halim. I'm the student from UIN Sunan Gunung Djati Bandung.
Unfortunately, I cannot
Repeat
hear
again.
the question.
Okay.
Okay.
Is that my voice is? Can you hear my voice? Because my network is so bad.
Okay. Yes, you can.
Yes. Yeah.
Okay. My question is, Elon Musk once said about AI is more dangerous than nuclear. Then, what is the prevention before so that something unwanted happen? For the example, maybe AI can dominate the human race. Thank you. Can you understand my question?
Yeah. I can understand your questions. Well, indeed, there is a debate on whether AI is dangerous or not to the human, to mankind. But I believe that AI ethics should be followed by people that doing research and development and applications of AI. So, for example, there is a huge discussion about trustworthy AI in which AI should, for example, protect himself from the attacker. That's one point. But also AI should avoid a bias because of the data and also because of the algorithms. And one other thing is that AI should be explainable, in which we consider the AI not only as a black box model, but we can, as a user of the AI, can understand why a certain decision or prediction is made by AI. I believe that by following AI ethics, then we can, for example, develop an AI systems that work together with the man or with the human in a collaborative way. And I experience developing and designing the national AI strategy for Indonesia. 2 years ago, it was launched by our vice presidents. And in this national strategy, we put AI ethics as one major components of the AI development in the future in Indonesia, and that should be established early, so that a dangerous AI will not resulting from the development of AI in Indonesia. But I agree that there is much or a hot debate about whether AI will be more dangerous than human. But I believe that we can make, or we can produce an AI system that is friendly to the human, and will human and the machines can work together to make a better world. So that's my answer.
Okay, agree or not?
Well, I cannot enforce you to agree with my opinion, but that's what I believe will benefit. AI will benefit to the mankind.
Thank you, Professor. Okay, we only have time 10 minutes more. So for the next questioner, I give time for Mr. Indra Yasri. Maybe you can we can unmute Indra Yasri.
Yes,
Okay.
thank you. Okay, thank you for the chance for me to raise a question. I'd like to ask you, Prof. Bambang, that related the challenge that we are facing in the AI into the hardware implementation. That as you know, that we are in the academic, we have limited cost, limited budget to conduct this research when we are implementing the AI algorithm into the hardware. Usually that we know that we can implement this AI either to microcontroller or to the FPGA. So I don't know, maybe you can share about how to deal when we have limited resource of the hardware, then we can make efficiency in the hardware implementation. So we can get because the issue sometimes is real-time performance. I can say that we have two cases, like one, when we compare the AI into the database. Let's say I talking in the surveillance camera. We want to compare some data that we have in database, and then we want the AI to give decision according to the comparison that conduct by the AI. Okay, for this case, maybe for autonomous car also implementing this. So how your suggestion when we are dealing with the limited resource of hardware, or maybe you can share how you deal, especially for your project in the tram, what is the minimum requirement for your hardware to support your AI algorithm? Because you saw just now some performance, and then maybe if you want to share, perhaps please share what is the hardware resource that you are using for your project. I think that's all. Thank you. Before that, Prof.
Thank you for your question. So let me start by explaining that recently deep learning model requires a lot of or a huge computational resources, particularly when we use a very deep neural networks. So very deep neural networks uses a lot of hidden layers, and the computation is becoming more expensive computationally. So at least there are a number of developments nowadays in terms of hardware implementation of the AI model. One is the so-called AI on edge, in which we use the light hardware, computational hardware, such as, for example, NVIDIA Jetson Nano, NVIDIA Sapphire, and also some low-cost microcontrollers such as Raspberry, or maybe also BeagleBone, and also a number of single port computer. So people is trying to develop a lighter AI model, which enables him to execute the model into the low computational hardware. So that's one areas of development. The other area is that a number of companies is trying to develop a specific hardware to make a lighter computation for executing the AI model. For example, Google come up with the tensor computing hardware, and also other companies use the FPGA, for example, to speed up the computation of the execution of AI model. This is the second area. And the third area people also developing a framework which enables them to execute deep learning model, for example, in a low-cost hardware using, for example, Intel come up with the Open Vino. So that is the lightweight version of the computational framework for the AI model. For our autonomous tram development, we use basically a supercomputer because we aimed to implement all the deep learning models that we develop on one embedded graphical processing model. So we use the NVIDIA embedded GPU, which is basically a super computer, which enable us to perform all the algorithms and all the AI models on this platform. But of course, I know some development for the autonomous robot that use more, more computationally less expensive hardware, in which they use some kinds of single board computer or a micro controller, but the result is that only a certain AI algorithms that can be run on this low-cost hardware because there is a trade-off actually between the speed of the computation and the precision of the deep learning model.
Okay, thank you very much, Professor Bambang Riyanto Trilaksono. Wow, it is an interesting discussion, but unfortunately the time is limited. We apologize. Now we stop this online discussion. Maybe for the question in chat room, Professor can respond directly if you would like. Okay, thank you very much.
Yes. Okay.
Okay.
Thank you.
Okay, thank you very much for the participants. Now we want to give the certificate for Professor Bambang for the committee here. Here it is the certificate. Thank you very much, Professor.
Thank you very much.
Nice to meet you. Another webinar.
Nice to meet you too.
Okay, thank you very much. Before closing this session, I will announce the participant who get door prizes. Okay, who is the winner? Okay, for the first is Said Taufik Rizaldi. And the second is Muhammad Ihsan. And another is Indra Yasri. Okay, good luck. Thank you very much for your participants. For the committee, the committee will contact you after this session. Okay, I close this session with Alhamdulillah and Assalamu'alaikum warahmatullahi wabarakatuh. See you.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much.
You're welcome.
Okay, thank you very much, Dr. Star Handayani, and of course, to Prof. Bambang Riyanto Trilaksono for the briefing explanation today. May it will be very beneficial for all of the participants today. So let's keep on our agenda and still stay tuned for the second round. We still have some door prize for you too for the second sessions. So this session will be delivered by Dr. Laurent Bobelin, who will share about the topic security and high performance computing. Ms. Dian Saadilah Mailawati, Eskom MT, will help us to lead this session. Ms. Dian was born 26th of May in Cirebon, and she is an informatics lecturer from UIN Bandung. Currently, she is a doctoral student at University Teknologi, Malaysia, Malacca. To Ms. Dian Saadilah, now is your time.
Okay, thank you, Ms. Okay. Okay, hello. Can you hear my voice? Okay. Thank you, Miss Melva Yola. Hi, everyone. Good afternoon, ladies and gentlemen, and Assalamualaikum warahmatullahi wabarakatuh. Welcome and thank you for attending the international webinar series that organized by Universitas Islam Negeri Sunan Gunung Djati Bandung, Universitas Islam Syarif. To be honored, I'm Dian Saadilah Mailawati from Department of Informatics, Universitas Islam Sunan Gunung Djati Bandung. Will guide you all in this second session with the topic security and high performance computing. Before we begin the main agenda, let me introduce our special keynote speaker here, to Dr. Laurent Bobelin from INSA Saint-Ophal de Loire, France. Hello, Dr. Laurent. Are you here?
Hello. Yes, I am.
Okay.
Can you hear me? Oh, okay. Yeah.
Yes, can hear your voice. How are you, doctor?
I'm fine, and you?
Okay. Thank you. Nice to meet you, and thank you for coming. Dr. Laurent is an assistant professor and head of system and data security team at LIFO Laboratory since 2016, and he got his PhD in computer science with thesis title Network Topology Discovery for European Computing Grid (EGEE), and conducted the postdoctoral research on disabled children data security. And his research interests are high performance computing and distributed computing. And also he published many publications with those research topics. Ladies and gentlemen, this session becomes two sections. First section is explanation minutes and followed by question answering session around 25 minutes. And the audience can raise hand or send the question on the chat box. Okay, without any further ado, I would like to invite Dr. Laurent Bobelin. Please welcome, doctor. The time is yours.
Okay, thanks. I'm going to share my my screen. I can't for now. Sorry. I think I don't have the right to share my screen by now.
Oh, the committee, can you help Dr. Laurent? Wait, doctor, I will check the security. Yes. Okay, can you try again?
Not yet, actually. I still can't share my screen.
Please, can you share again?
I'll try this one. I still have only access to the whiteboard. It's the only thing I can share, but it's a whiteboard, so it's not going to work.
I have allowed the share screen for you.
Yes, I ask myself, maybe I should try to reconnect to the session.
Oh,
I'm
okay.
just gonna stop and come back in a few seconds.
Okay, okay.
Sorry for the.
Oh, ya. Sudah selesai.
Okay, ladies and gentlemen, please wait for Dr. Laurent. He will rejoin the session.
Sorry, can you hear me?
Yes, I can hear you, Doctor.
I still can't share my screen.
Oh, maybe the committee can help him to share his presentation.
But actually, I think I have all the necessary rights. It's strange. I'm going to try with another client, a Zoom client. I'm going to be back in a few seconds.
Okay.
Hi again.
Yeah, hi, Dr. Laurent.
Yes, I'm trying. Sorry.
Yeah.
Maybe I should. You can still see my screen.
I cannot see your screen, just black screen.
Black screen. Yes.
Yeah.
You
right.
And
The screen is black, right?
the screen is not supposed to be black. Actually. So maybe I've sent my my slideshow because I think it's going to be complicated to do it like this, but I don't know why it does not work. Maybe you could try to open my slideshow, and then I'm sorry because it's going to be quite painful for you, but to go each time I will advance my slides.
Oh, now we can see your screen, Dr. Laurent.
No, it's Lestari screen.
Oh,
But
Lestari. Oh, yeah, Lestari. Okay, okay.
Yes, if Lestari, if you can do this, it's going to be okay.
Oh, yeah, okay, no problem.
Sorry for the technical problems, but I don't know why what is happening. Thank you, Lestari.
Thank you. Okay, please, Dr. Laurent, the time is yours.
Yes. So today's talk, I'm going to discuss about how to efficiently protect high-performance computing computation. The basic idea is, can you go to the next slide, Lestari? Thank you very much. Also, sorry, I would just like to thank first the audience to attend this meeting and you, Diane, for organizing this, and all the organizers also. And so today I want to discuss about two subjects that are quite usually opposite. When you are dealing with HPC systems, it exists since decades, and it's very good at using resources efficiently with well-known paradigms, well-known tools and algorithms. And when it comes for security, there's quite and it's quite an opposite way, because we try to enforce everything. So it means using resource to just to do security. And there are many threats that exist for HPC system. Basically, one can want to spy the system, to falsify data, and the result of a system, to stop it or to destroy it. And the question I want to discuss about today is, how can you secure high-performance computing while preserving good performances? And so who I am, thanks Diane to introduce me. I did my PhD on grid computing, which is a kind of old now system that was linking clusters in order to do clusters and data centers in order to do very huge computation. I've worked with a Large Hadron Collider in Geneva on some Higgs boson detection and this kind of stuff. I spent 8 years in the industry sector, and then it's since now it's been 15 years that I work in academics, working on HPC and cybersecurity. And I'm an assistant professor at INSA Centre Val de Loire, at Laboratoire d'Informatique Fondamentale d'Orléans, named as LIFO lab. I'm the head of a team which is specialized in cybersecurity, which is called System and Data Security. And my research topics are cybersecurity and privacy, zero trust architecture, and we're going to discuss about this later in this talk, and HPC. Lestari, can you go to the next slide? Just okay. So let's begin to work to discuss a little bit about HPC and give some background about it. When we are doing serial computing, sorry, yes, this one is good. When we are trying to do some classic serial computation, we just find a problem and we cut it in different discrete series of instruction, and the different instructions are executed sequentially on a single processor. And you have only one instruction that may execute at any moment of time. Can you switch to, yes. So for example, if you are just trying to add two matrices, then you can just cut in lines the matrix and finally execute it. When you are doing parallel programming, you take the problem and you cut it in discrete parts that can be solved concurrently. And each part will be a series of instructions, and each instruction from each part will execute simultaneously on different processors. And we need to have a kind of control or coordination mechanism. So this is for parallel programming. And when we're dealing about high performance computing, it relies on this parallel programming stuff. We're trying to cut in different pieces some big problem into smaller problems that we can execute using either, and most of the time both, parallel programming. So it means using programs to solve it concurrently, some sub problems, and distributed computing, so using multiple machines to run multiple computers. So the computer resource we have in each single computer, you have multiple processor cores, and we have many computers connected by a network, up to thousands or even billions sometimes. So it means that we have a very large infrastructure. We are working on this. We are working with. So this is for HPC. So for example, when I have a program, I can split it in part. And if you can go to the next slide, just to give you an idea. No, before I was just cutting in rows, the columns, the different, sorry, it's kind of the rows, the different part of my problem. Now I can use rows and lines in order to make my matrix addition easily. And there are some pretty popular techniques when we are writing HPC applications. Message passing is one of the most used when we use messages to communicate between a processor, host, and this kind of stuff. And this is quite popular. We also have, we use shared memory or shared storage mostly when we are doing multi-core applications. And one interesting paradigm is master-slave, when we have some master that will decide which work all the other nodes that will act as slaves will work on. There are some stateless services-based architecture. There is some pipelining that we can do. Also, one classical stuff is to divide and conquer. So we try to divide the problem in sub-problems, easier to solve. And actually, the question is, are all those techniques impacted the same way when we are trying to secure application? The answer is no. And some are better than others. So when we try to deal with cybersecurity, we have some main concepts to deal with. Basically, we have very few basic security properties we want to guarantee. First one is confidentiality. It means that if you are between two persons communicating, you want to ensure that nobody else than the two persons communicating will have access to the data you are communicating with. Second question is authentication. Is exactly how can you ensure that you are talking to the good person? How do you ensure that it's not somebody else that will try to embody that person, but it's not? And finally, the integrity of the message is when we are discussing with another host, let's say, how can we ensure that the message is not corrupted or changed? This is the three basic cybersecurity properties we want to guarantee, to enforce. And to do so, we want to ensure these properties when we are securing the exchanges, but also the storage. How do I know that who has stored something, who has access to something? And also when I'm doing computation, actually, how do I know that it's exactly the person I think it is that is computing on my computer? And we have some different tools, usual tools to do it. First one, and well known, is cryptography. So you try to encrypt the messages, and you have all the key protocols, the key-based protocols that you may know. You have formal models that helps to ensure that in no case you can have data leaks and this kind of stuff in programs. And finally, system design. And system design is something where you can try by constructing your system to enforce it. And so this is the main approach I will discuss. Other approaches to enforce the cybersecurity is to do continuous enforcement or continuous audit. It means that we will try to ensure that nobody is intruding in my system, in a system, on the system is still safe. But we're going to focus on how to design this kind of stuff. So Can you, let's start it? Okay, thanks. You have many different types of attack. And I think most of you know many of them. So for example, DDoS, distributed denial of service. The basic idea is to try to make a service which is on the web to stop to respond to service. The other one, which is well known, is the ransomware. So somebody will try to infect your to corrupt your your computer and try to encrypt your data and then ask you for money to to decrypt your data. And this is somewhat destructive, or at least it wants to stop the system. And when it comes to spying or falsifying, you have many methods. One which is main known is man in the middle, where the attacker replaces one of the equipment in between two hosts communicating in order to read all the data that will come and go out and in from the different hosts. And actually another one in the inference from observation. And this is a classic attack you have in the cloud paradigm, because even though you are trusting in a way the person you are that is your provider of computing power, even though it does not actively try to destroy what you are doing, it's going to observe all the packets coming in and out from the services he will host for you, and he will try to infer knowledge. So it's spying. And okay, why some people attack HPC computation? First, one of the first ideas to steal scientific knowledge means that we try to have some advance as a state or as an institution, and it's usually foreign countries that try to find what you are working on. Identify what is simulated. We're going to discuss this later. There are some cases where you just don't want people to know what you are trying to compute. And still industrial knowledge also, because you have some algorithms that are protected by the law, and people may want to retro-engineer this algorithm and to find out what you are doing exactly. And actually, there are actual threats for HPC, because when you are working on clusters on a data center, for example, you are accessing from it remotely. You are not usually you are not into the data center when you are trying to start a new HPC application. And also, most of the time, the cluster you are using is shared. So it means that you may have some other users that are corrupted or malicious, and they may want to steal what you are doing. And sometimes, even if it's sometimes you will have some computing resources that are hosted externally from your institution. So there are different threats and different threat models in cybersecurity, and there is one special model that actually perfectly fits with this kind of threat, which is called zero trust. Let's start. Yes. The basic idea of zero trust is that we won't trust any communications. It means that we suppose that the attacker has almost full control of the channel between two end systems. So he can read anything on the network and may remove, change, or add new packets that are not part of what you are writing, but what you are exchanging, so as to make people think that he is you, and for example, this kind of stuff. And so what it means is that even though the end system you are trying to communicate with, for example, your data center is secure, as you are going through an untrusted communication channel, you can be sure that the packets you will receive are the good ones. And also, second thing is that we just want to not trust the execution environment, because an attacker may be curious or want to falsify your data, and it can read any memory you have not encrypted, and it can modify any memory that you have not encrypted. That's the case, for example, when you are trying to make some computation on hosts that are hosted by someone which is malicious. And to give you an exact example of the kind of application we want to secure, I will discuss about Metas. Metas, it's a code we are working since 3 years now on it. It's some computational fluid dynamics code based on finite element method. So we have a lot of, it's mesh based. So we are just trying to to make a discrete cut of the space into mesh. And its main aim is to simulate explosion into building and structure. As we are working a lot with some military related industry, it's mainly used by some people that are doing missiles and weapons. And so into that code, we have a mesh modeling the targeted system, and the gradient calculation, some gradient calculation, completely standard one. And we have into this code some method based, it's quite technical, on something called conservation element, solution element, that has to be protected because it has been written and it's protected by some industrial intellectual property. And so what do we want to secure in such an application? First, we want to secure the mesh itself, because, for example, when you are trying to simulate how large should be a weapon to destroy a building, you don't want the person that you may send the weapon to be able to identify that you are trying to destroy his building. So first thing is that we want to hide from any observer what we want to simulate, what structure we're trying to simulate. Second thing is the computation integrity. So we want to be sure that we have correct results. And finally, as I said before, we have some library that we want to protect from spires. So this is the example I will discuss about. And how do we do securing all this stuff? I'm going to discuss first about the networking part. Okay, so how do we secure the network? And then how we secure the computation itself. When we are doing usual, actual, traditional security concerning networks, we talk about perimeter-based security. So we have a big network and we cut it into different zones called segments. And in between each zone, we try to deploy some firewall that will try to figure out who is trying to enter, which packets are trying to enter, and to discard unwanted packets and unwanted traffic. And for each zone, we have different level of trust. And that level of trust will allow you to determine which network resources you are allowed to reach. Can you go to the next slide? So this is usually perimeter-based security, sometimes called fortress security, because the basic idea is that you will have different walls that will separate you from sensitive resources. And when you are dealing with a HPC, usually you are trying to access to the resource from your home network or your institution network, and you go a first firewall coming out from your home network to go to the internet. Then from the internet, to the what is called the institutional network DMZ, so demilitarized zone. It's a place where you can access all possible services that will be exposed by an institution. Then from this DMZ, you can have access to a front end, and the front end finally, which is on separated zone, and then finally you can access the cluster and the cluster network, and then you can play your application. And okay, and what can be done from here? First, the attacker may be on your home network. It may be you indeed. If you, for example, try, you have positively answered to some phishing mail, and somebody installed some tool to remotely take control of your computer, then the attack may actually come from your own network. So it means that any user cannot be trusted. We have to be sure that even though the user is identified, his device is not corrupted and his behavior is correct. Also, as the traffic goes through the internet, we have some possibilities for an attacker to come and attack from the internet using pretty standard techniques. To go in from the DMZ, you can also have different. For example, if you are in an institution, in the DMZ, you can have your website and the access for the front end. And what it means is that somebody may attack the website, okay, the web server, just in order to have access to the DMZ and to the other computers within the same zone, and then try to attack those computers. Then finally, you can also have some person that will attack directly the front end. And so it means also that if, for example, the attacker has attacked the home network, it can go directly to the cluster network in order to attack and to spy other people using the same network. So there are many possible attacks. Just to give you an example of a very, very standard attack, usually you have, and I'm pretty sure anybody here has received many phishing emails. What is done usually is that it asks you to go to a website or to download something. And this will compromise your machine. Okay, and usually what will do the attacker, what will be installed is something that is called a remote access tool, or RAT, and it will give the attacker the possibility from your host to execute any command. So it will be a command line for him, and he will have access at your host, and then after he can do some what we call lateral movements. It means that inside some segments, some in between two walls that we have, you trust anybody into your home network. So you trust anybody which is in the same network as you. So you can do lateral movement without all the firewalls try to intercept and to stop the traffic you are trying to do. So what he will usually do is that he's going to try to find some privileged workstation. For example, if you are into an institution and you are a user of an HPC resource, you may have some administrators that will also use and administrate the cluster you are using. And so what's the basic idea is that, okay, if you are into the same institution, then the administrator computer is in the same network as your computer is. So we try to, the attacker will try to find his workstation and then try to generally brute force his password. And then when it's done, it can have local privilege escalation. And so steal the cluster administrator password, and then it can use just updates that it will upload on the cluster just to compromise the cluster itself, to allow just to have some data leaking out of the cluster. Basically, you will try to, what the attacker will do is that he will try to install new packets with some corrupted stuff, like if you have any job submission, he will send a copy of the job submission to an external host. And this will give the ability for the attacker to spy directly what you are doing on your cluster. And so it means that you can easily compromise any resource using traditional. So can you go to the next slide, please? Thanks. Just a few words on a classic attack. It may be initiated by the victim itself. So if you are answering positively to a phishing mail, then it means that you actually initiated the attack. And a firewall may help to mitigate the attack, but as you are it's completely it's pretty hard to try to sort out what is regular traffic and what is not, because you're a normal user and you're allowed to do stuff. And second thing is that when you are trying to do this mitigation using firewalls, it means that you have to go in depth into packets, and it slows the traffic. And so the problem is that we can't stop lateral movement. Can you go to the next slide? So the question is how I can stop lateral movements. How can I deal with insecure and trusted networks and do better actually that the normal perimeter-based security? So we have two interesting tools that can be used for security, which is called SDN and NFV. SDN is a technique, software-defined networking. It allows you to do kind of fine-grained network segmentation, not based only on the device, but also on the user and the targeted application. And this is supported by any modern device, either physical or virtual. It means that if you are using virtual switches, you can use SDN to control them. And it allows central management and orchestration. And the second one is NFV, so network function virtualization. The basic idea is that you can dynamically deploy services such as firewall or NAT or something that will enforce your network security. And you can do it dynamically. And so this is completely complementary to SDN. And it allows you to enforce security on deployed on-demand networks. Can you go to the next slide, please? So just to understand how software-defined networking works, usually we'll try to give the example of the usual root computation in a network. So we have what does software-defined networking? It is that separates logically two different things. The data plane, which actually forwards when I have a packet coming into my network, into a switch. The switch knows that, okay, this packet, the receiver should be, let's say, machine A, and for machine A, I should go on switch, let's say 2. Okay, and so this is just basically some pattern matching with packets that will send, that will forward the packets there. But how do we compute those patterns that we should match? There is some algorithms, just like digital algorithms or something like that, that will that are computed in each switch or router that will manage to calculate the route. When we are working with software, yes, that's it. You can go to the next slide. When we are dealing with software-defined networking, we just switch to a distributed algorithm, so to some remote, usually central controller, which will compute for each of the different switches on my network what are the rules that he should apply to the packets. And this helped us to make comprehensive filtering of packets, because we can use this to enforce or discard traffic at a central point. So we can learn from a central point. Can you go to the next slide? Okay, and network function virtualization is just an idea that will go just like it's basically the same idea as you have when you have an hypervisor and you are trying to virtualize computing power, except that we are going to do this on network functions. So you have some devices that will works like hypervisors, and you will deploy dynamically different network function in it, and it helps to enforce security on that. Can you go to the next slide? Okay, basically how it is done, you have the virtual network functions themselves that are installed on some virtualization infrastructure, the NFV infrastructure, which is at the bottom. And we have some NFV management and orchestration, because you have to coordinate all this thing. And so those are the three big bricks that will big components of an NFV architecture. Can you go to the next slide? And so there is some architecture which is called Zero Trust, which is an answer to the Zero Trust threat I discussed before. The basic idea is we do not trust anyone. We do not give trust anyone without evidences. So we allow connection only if we have enough confidence on how secure the network flow is. And so it means that each time a flow is started, we evaluate if we trust enough the flow, mainly three things. The user identity. Can we trust that it's exactly this user? And even if we trust the user, his device can be corrupted. So we base ourselves on the fact that the device is secured, all the patches, the security patches are installed, and this kind of stuff. And actually, we try to see what is the usual workload in between the user and the application you want to access, in order to calculate some trust score. And this trust score will allow or deny access to the flow, to the network. And we will use SDN to centralize this decision. And so the network will discard dynamically or allow the traffic dynamically. And we will use NFV to deploy packet analysis when necessary. So if you go to the next slide, just to give you a big picture. So each time a packet from a new flow comes, then the network calls the remote controller. The remote controller discusses with policy engine, which will go to different database to calculate the trust score. And then the enforcement engine say to the remote controller if the traffic is allowed or not to go through the network. Can you go to the next slide, please? So this is an efficient threats answer to threats that you can have on HPC computation and on the network part. And nowadays, all devices allows you to use Zero Trust. You have many different things that are coming with the Zero Trust principle. I did not. I won't go into too much detail, but we try to cipher as much as possible the network traffic, and we try to renew the authorization, because, for example, you can have a long-term communication between two hosts, and at what time one of the hosts will be corrupted. And so we need to renew the authorization regularly. And what it means that we will need to adapt the HPC application to reduce the security overhead, just to take into account the fact that, okay, we will have to renew some stuff, and we will have some initial cost when beginning to discuss between two hosts. Can you go to the next slide? And so this was for the network part. How do we secure HP computation, the computational part? The threat is that the attacker can read your data, falsify your data, program or corrupt your program to stop it in a shell of infrastructure. So how do we stop these side attacks from malicious computation on the same host as the one we are using? Can you go to the next slide? Basically, you have some solutions that you have on most of your mobile phone now that are called TE for trusted execution environment, and that guarantees to have some part of code and data loaded inside this TE to be protected with respect to confidentiality and integrity. But it's usually some portion of your resource is very slow. You can have some implementation on actual nowadays classic Intel, for example, a processor, but it's really slow, so it's not suitable for HPC. So what we can use is some VM hardware-based security, because when we are using VM-based virtualization of resources, then without entering into too much details, you have some security which is provided, hardware provided. For example, for a VM, it's almost impossible to go directly, at least, into another segment of memory for another VM because it's isolated at the hardware level. But the thing we still have is, okay, as I said, between two VM on the same host, it's complicated, really complicated to access to the memory zone of another VM, but from the host, it may be easier. So the question is, what if we don't trust our host? And can you go to the next slide, please? We have nowadays, it's quite new, we have some solutions that are hardware-based solution to enforce that trust into the host. Actually, you have MKTME and SCV, it's Intel and AMD. It does quite the same thing. And what it does, it provides you some on the IOMMU component and on the MMU component of your hardware. It provides you a way to directly encrypt on the fly your memory. And so how does it work? You provide a key, and so he will encrypt directly in memory the data you will host, and so the host cannot read the memory segment of the VM he hosts. And additionally, as it's hardware based, it has very low overhead, but the init time is increased. If we can go to the next slide. On the other hand, we have, to go faster, we have container security. The container is another way to virtualize some computing resource. But the problem is that it's just an isolated process within a system. So you can have some full vision of the container when you are the host. You have some security without entering too much details of what you can have between two containers, but not from the host. And so you have finally one solution, which is to use what is called Kata container. It's a lightweight VM plus OCI-based isolated containers, so containers that will be isolated from themselves. And what does it do? It uses the MKTME SCV protocol to encrypt, so the VM will be isolated from other VM and from the host. And into it, you have a fast running container, so you will be allowed to use it quite securely. Can you go to the next slide? I'm sorry, I'm late. So how do we do it in practice? Can you go to the next slide? Basic idea is to use MKTME and SCV Kata containers to run securely the code. And it has slower on it, but it isolates of some secure processes. And we will use some zero trust, but it means that we have slower flow in it, and we need to configure it authorization. I mean, that's very technical, but you have some parameters you can tweak to deal with the auth renewal problem. Okay, and so how does it impact the application I discussed with? You have to rewrite it just to use the master-slave paradigm. What it will what useful to do is that you will have the application master that will schedule the different parts of the application into the system, and will decide which are the application part you should secure, and you are sending it to a secure worker that works with some kata container on it, and which part are not, and that you can do it on normal workers. And so it means that we have completely for the Metas application rewrite the application so as to have good performances. And so it means that we have to change the structure of the code, and also to do some secure slave and enforce the fact that you are secure and secure. And also we have some infrastructure change to do to deploy SDN-based zero trust policies. And it means many different things. You have many tweaks to do into the infrastructure. Can you go in the next? So as to conclude, securing an application, an HPC application, it needs some in-depth modification into the application structure itself if you still want to have good resource use. And also on the opposite way, you need to tweak many parameters and many policies in the zero trust architecture in order to adapt to an HPC load. And there we did for now the secure computation stuff, and now we are on the process of trying to adapt zero trust policies and also the mesh obfuscation. We're going to add it to this exact Metas example to do it. I'm done with. Thanks for your attention, and sorry to be late.
Yeah, thank you for your interesting topic, Dr. Laurent. And in this big data era, I believe that we need high performance computing, and the issue is about security. And yeah, I think cybersecurity has become popular research today. Okay, next section, we going to the question answering section. Any question from the audience? You can raise your hand to ask question directly. Any question from the audience? Okay. Okay, maybe several questions from me, Dr. Laurent. I hear about ubiquitous computing. What's the difference between ubiquitous computing and high performance computing? And the second question is, which one more important and become a priority between network security and computation security for high performance computing? Thank you.
Concerning ubiquitous computing, it does not serve the same aim as HPC. When you are doing high performance computing, we're trying to calculate something. Usually it's you have many applications, scientific applications, just like simulating earthquakes and this kind of stuff. So it's big computation. When you are doing ubiquitous computing, it's and you want to do it very fast. When you are trying to do ubiquitous computing, try to have some resources, but without that question of performances. And so what does it mean? It means that you don't have the same criticity, level of criticity, first, about your application. And second, you don't have the same requirements concerning performances. And also usually, so to answer you, is it more important to secure the network or the computing resource? If one is compromised, if the network is compromised, then you will be in serious trouble because the attacker can attack you. And if you have your computing resource compromised, then the attacker can pretend to other services that it's you. So both are equally important. I did not discuss this, but we use the term of end-to-end security, usually to say that you need to integrate, completely integrate the security into your system if you want to secure it. Because actually, when you have just one, if you have just one security hole in your whole system, your whole system is compromised anyway.
Okay, thank you for your answer, Dr. Laurent. I invite the audience, maybe any question about HPC or security. Okay. Yeah, it's interesting topic, Dr. Laurent, about network security, SDN, and NFV. Should we conduct both of the network security, or just only one we implement to our system, Doctor?
Sorry, can you repeat the question?
Yeah, about network security, there are SDN and NFV. Yeah, we have to implement both of them, or just one network security that we can implement.
Actually, that's when SDN is something that will help you to manage your network resources efficiently and discard or low traffic. While when you are doing NFV, you are trying to deploy services like firewalls and this kind of stuff dynamically. So it comes together. Both SDN and NFV are not, both technologies are not necessarily related to security. For example, with NFV, you can deploy some load balancers that will allow you to dispatch all incoming traffic to different hosts, for example, and it has nothing to do with security. So this is for NFV. For SDN, it allows you to also possibly efficiently equilibrate the load, the load you will have into the network, and it allows you to do some segmentation, fine-grained segmentation, because it allows you to go through deep packet inspection. And one big advantage you have on SDN, which is not related to security, it's something that is because I'm reading that somebody have written about AWS. For example, when you are going onto either, for example, Google, it's the same with AWS. Google has some private one, so worldwide area network. And at the end, it's linked to different data centers that will host cloud resources. And how do you ensure that you will separate from the different users you will have at the end that will use your cloud computing resource, possibly worldwide? All the network routes and all the isolation is done using SDN, a single SDN that will coordinate all the hosts worldwide. So it allows you to split into different subnetworks for your different users your network. So it's really useful. It's not necessarily only related to security, but also to performances. And so you have many different usage of SDN that are not only related to security. So it means that SDN and NFV are both important, and it's widely accepted nowadays in many institutions and big companies, and even with people who does not have that much knowledge of SDN, for example. For people that are into network, we use a stackable switch. So it means that you can buy several switches, and actually you will see it from the administration point of view just as one big switch. And this is done using SDN technologies, for example. So even though you may not identify SDN as the thing you are using, it is. You have many ways where it is already implemented. So both are important.
Okay, thank you. There is a question from Muhammad Jasman on the chat box.
Yes.
Doctor. Yeah. About.
Yes.
I've heard a lot about AWS parallel cluster, and it seems expensive computing resources.
That's
any idea what kind of topic to be researched? Yeah.
Related to HPC, you have at one time you had many things related to desktop computing, for example, which is something where you try to dispatch load. You may take a look at Boeing. It's from Stanford University. And it's something that allows you to dispatch load on voluntary hosts because it's true that it's really expensive and complicated to have an HPC infrastructure. And thing is that you can actually use some smaller computing resource, just like your desktop that you don't use at night, for example, to compute some stuff. You also have some interesting things you can do. For example, when you are, I don't know if you know the Pixar movies that Disney has bought recently, that are animated, 3D characters that are moving inside this. This is done actually using some HPC low energy resources. It may not be a question about how it works. It works using some old computing resources that are bought at low price, and the energy that is dissipated, because you know that when you have an HPC infrastructure, it produces a lot of heat, and this heat is used for industries that needs to have some heat. Let's say that you have some oven to make work, and so there are some companies that actually buy some old computers to use them to install it on into some enterprises buildings that need some heat. And so this is one of our ideas to work with a limited budget. And after that, question is how limited is your budget? Because also you have many different theoretical aspects that you can work on. So, and actually both with security, because I did not discuss that much about trust core, but how do you trust somebody when you have been disconnected and reconnected? This kind of stuff are complex theoretical problems.
Okay, thank you, Dr. Laurent, for your answer.
You're welcome.
Once more, I want to invite audience. Maybe any other question? No. Okay, if there is no question for Dr. Laurent, maybe we can close this session. Dr. Laurent, thank you so much for your time and share interesting knowledge about HPC and security in this webinar series. See you next time and keep healthy, doctor. Okay, and we have appreciation certificate for you. Okay. Okay, here's the certificate for you, Dr. Laurent. Thank you so much. Okay, last but not least, okay, I've got names who win the door prize. Wait a minute. Okay. For the door prize today, we'll go to Muhammad Jasman. Congratulations to Muhammad Jasman, and the committee will contact you. Okay, this is the end of this session. Thank you for your attention and sorry for any mistake. Assalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi wabarakatuh. Thank you.
Okay, back to me, to the Master of Ceremony. Thank you for all the sharing from Dr. Laurent Bobelin and Ms. Tia Sadilah Mainawati. May all of the interesting knowledge that has been shared will be beneficial in the future. For all of participants, don't forget to fill your absence that has been given in the chat room. And only participants who will fill the absence will get the certificate from the committee. Now we come to the last agenda, is closing ceremony. Please to Dr. Hajah Hasniah Aliyah MSI, the Dean of Faculty of Science and Technology UIN Bandung, to give her closing statement. Okay, I correct for the closing ceremony. Maybe this is the last statement for me. Many thanks to the speakers, moderators, and participants who have listened and going through this webinar from the beginning to the end. Lastly, I have one more pantun for all of you. Buah nanas khasnya dari Riau sini. Dijadikan selai, enak sekali. Cukup sekian webinar series 2 ini. Sampai jumpa di tahun depan nanti. On behalf of the community, UIN Riau and UIN Bandung, apologies for all the wrong statements and for all the wrong actions. And congratulations for all of the winners. Finally, see you in the next year in International Webinar 2023. And wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.